We're here to talk about children's counting. Hi, my name is Robert Hunting. This is one of several in a series aimed at explaining how young children learn mathematics. Evidence of counting ability by young children is highly valued in our community. But just what is counting? I will discuss 4 important aspects of counting skill: development of the standard number word sequence, coordination of spoken number words with acts of touching or pointing at items, realisation of the cardinal meanings of counting words, and capacity to count on from a certain number in addition situations. Certainly, the skill of verbalising number words in sequence is very important knowledge, but only part. Essentially, learning the sequence of standard number names is a memory achievement which gradually extends in range over several years. Typically, young children will recall part of the conventional sequence correctly on many occasions, followed by repetition of an unconventional sequence, sometimes stable, sometimes not. Karen Fusen identified 3 zones in children's efforts in learning the number word sequence: a stable conventional zone, followed by a stable non-conventional zone, followed by an unstable non-conventional zone or spew. By stable, she meant that over repeated observations of children's verbal counting behaviour, similar results would occur. For example, a child might say 1, 2, 3, 4, 5, 6, 8, 9, 10, repeatedly missing the count word 7. So the stable conventional part is the words 1 through 6, and the stable non-conventional zone, in this case, is 6, 8, 9, 10. These 3 zones are gradually extended as children have more experience, practice, and social interactions with adults and older children. To be a rational counter, a child will coordinate verbal number word utterances with acts of pointing or touching physical items in such a way that for each spoken number word, one and only one item is touched or indicated, with no item in the collection omitted and no item tagged more than once. Teachers will understand this coordination as evidence of one-to-one correspondence. In this clip, Tom, aged 2 years and 7 months, has neither mastered the standard number word sequence nor one-to-one correspondence, but he has got the right idea.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, don't!
1 month later, he does better with the verbal number sequence at least.
How many calves are in there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 7, 2, 2, 3, 7, 3, 1, 2, 3, 2, 10, 6, 7, 8, 9.
Twins Talia and Emily, aged 3 years and 5 months, seem to have mastered the first standard number names in sequence, but not the word for point coordination.
1, 2, 3, 4, 5.
Are you sure?
1, 2,
Sure it's not 6?
5, 6, 7.
Good.
1, 2, 3, 4, 5, 6, 7.
But more is involved. Young children need to realise that when the last item has been tagged, the number word associated with that item refers not just to the ordinal position in the sequence, but also refers to the cardinal value of the set of items just counted. For example, suppose there are 6 buttons in a collection. The adult asks the child, "How many buttons are there here?" The child will initially come to associate the words "how many" with an expectation on the part of the adult that a count is required. So the child responds by counting each item. 1, 2, 3, 4, 5, 6. The adult then asks, "How many buttons are there?" The child again responds by counting each item. The child will learn that the last count word is a sufficient response and eventually understand that the last count word implies a nested sequence of cardinal sets. When 2 is uttered, that word means not just the second item touched, but also that a set of 2 thus far has been counted. 3 means the set of 2 plus 1 more. 4 is the set of 3 plus 1 more, and so on. This is the last count word cardinal number transition. No one really knows how this transition occurs, just that it does in the course of children's development. See my video called Numbers and Part-Whole Reasoning for further comment. Counting on is a huge leap forward in the application of children's counting skill to solve simple addition tasks. A fairly sophisticated understanding of numbers is required, including relatively abstract knowledge of numbers associated with number words and numerals. It is best illustrated by a task where 2 quantities are to be added: 5 visible smiley face stickers and 7 hidden stickers. Luca, aged 4 years and 8 months, is not successful at this point in time. There are 7 counters under this cover. Look, a little quick sneak peek, right? And how many counters are on the board altogether?
1, 2, 3, 4, 5.
Oh, no, all together, see, including these ones. Can you do that? Figure that out?
You have to open it all the way.
What if we can't open it?
Can.
Well, you can, but you're not allowed to. How many's under here? Do you remember?
No.
I'll tell you one more time. 7.
Six, 7, 1, 2, 3, 4, 5, 6, 7.
Neither is Emily, aged 4 years and 11 months. There's some pink stickers. And under here, there are some other stickers that are hiding. You just see them. Can you see them? They're pink too. And I'm going to tell you how many stickers are under here. There's 7. Okay? There's 7 here and these ones here. Can you tell me how many stickers there are on this board altogether?
There's 5 here,
Yeah.
but I don't know what's here.
I told you what was here. Do you remember what I told you?
Sticky.
7.
7.
7. Hmm. What are you going to do? Can you figure it out? Huh? Why not?
Because I don't know what I'm going to say.
You what?
I don't know what I'm going to say.
You don't know what's here?
Yeah.
Didn't I tell you?
Yeah.
How many?
8.
No, I didn't say 8. I said 7.
7.
7. So if there's 7 here, and how many's here?
5.
How many's that all together? However, 2 years later, Luca demonstrates confidence counting forward by hundreds in the context of a bead frame. How many beads are there in this row?
10.
How many beads in this row?
10.
How many beads are there in this row?
10.
How many beads? How many beads in these 2 rows together?
20.
Oh, how many beads in these 4 rows together?
40.
Ooh, how many beads in these 5 rows together?
50.
All right. How many beads in these rows all together?
100.
Oh, wow. I think you're a metal giant. And if I went to count like this, 100 and another 100, how much is that?
So 200.
200 and another 100
300.
and another 100.
400. 500. 600. 700. 800. 900. 1,000. 2,000. No, 1,000. 1,200. 1,200.
You can discover more about how children learn mathematics by obtaining my books, What Children Can Teach Adults About Mathematics, and The How and Why of Teaching Elementary Mathematics, available through the iTunes Store, Amazon or Google Books. Visit my website at www.palm-ed.com or Facebook page at www.facebook.com/Hello Palm.